Good morning. This is your stat sensei, Mr. Spence, and this is Death Packet Proportions, problem 61 through 70. When an online news magazine asks viewers to click their agreement or disagreement, 300 out of 1,200 respondents agreed with the statement that the most practical way of becoming a millionaire is winning the lottery. I got to ask yourself. Well, immediate feedback stated that 25% of the viewers with a margin of error of plus or minus 2.5% agreed with the statement. Fine print claimed 95% confidence. What's the proper conclusion? Well, we always need to consider what our conditions were if we can. My question is, was this a random sample? And it's like, no, they just asked their viewers and they collected. They clicked in. So in this case, we have voluntary response bias. This was not a random sample. So we should keep that in the back of our mind when we're going through this problem. So they said 25%, okay, 0.25. So so we know that's p hat plus or minus the margin of error. So that's going to be 0.25 plus or minus 0.025, which gives me 0.225 all the way up to 0.275. All right. So that's my lower and that's my upper. We are 95% confident the proportion of viewers who believe the most practical way of becoming a millionaire is winning the lottery is between those values. Well, that sounds really good, but we should read further to see if there's something better because we still think this is voluntary response bias. Without knowing whether NP and N times 1 minus P are greater than 10, the calculation is inappropriate. Well, we have a news magazine and it's online and the question is, do they have more than 12,000 respondents or 12,000 people watching it? Probably, because it's online. Although it'd be nice to know that could be a problem. All right, that could be a problem, but we're still looking for the best answer. Without knowing whether or not the 1,200 are 10% of all viewers calculated, it doesn't have to be all viewers. It has to be less than 10%. So that one's wrong. The Z distribution was inappropriate instead of T distribution. No, should be a Z because it's a proportion. T is for means. So that's false. The data was not a simple random sample, so the calculation is inappropriate to begin with. Very first thing, simple random sample have to satisfy. Okay. Oh, did you notice how they tried to trick you and have you mark A? Would have been easy to fall for it without reading them all. 62. P equals 0.6. All right, so they're saying the proportion is 0.6. The alternative is greater than 0.6. Um, and against the alternative, P equals 0.7, the power is 8. Which of the following is a valid conclusion? All right, so if power is zero point 0.8, the probability of a type 2 error is, if power is 0.8, power equals 1 minus beta. So 0.8 equals 1 minus beta. Subtract 1 from both sides. I get negative 0.2 equals negative beta, make them both positive. Beta is 0.2. All right. The probability of failing to reject is 0.2. Well, 62B tells me the probability of failing to reject is 0.2 if it really is 7. Okay. The acceptance rate of a particular college is 58%. If one takes a simple random sample of applicants to this college and constructs a confidence interval estimate of the acceptance rate, which of the statements is true? The center of the interval would be 58%, maybe. The interval would contain 58%, maybe. A 99% confidence interval would contain 58%, maybe. All of the true statements, maybe. I don't like all these maybes. How about none of them? And I like none of them. And the reason I like none of them is because you took a sample, maybe your sample is at 57 or 50, 59 or 61. All right. And remember, confidence interval is not guaranteed to capture it. Even if it's 99%, there's a 1% chance that it doesn't capture it. So all of these are maybes, and we needed a for sure. Okay. So none of them are accurate statements. They're close, but not right. Which of the following statements is true? It's helpful to examine your data. That's cheating. You don't look at your data before to decide whether it's one tail or two tail. You decide before you design the study. Decide before you design the study as to whether there's going to be one tail or two tail. Don't do that. This is cheating. False. If the p-value is 0.05, the probability the null is correct is 0.05. No. If the null is correct, the probability of rejecting it is 0.05. The larger the p-value, the more evidence. No. Small p-value, lots of evidence. If the p-value is small enough, we conclude the alternative is true. Oh, we don't conclude the alternative is true. We just conclude that the null is false. All right. We don't prove this is true. So I don't like the word conclude. All right. So if the p-value is small enough, we conclude no, we just fail to reject the null. I mean, excuse me, not reject the null, fail to reject. We reject the null. All right. So we reject the null and we believe the other, but concludes a little bit strong. What's 100% case? We do not use sample statistics in the hypothesis. HO is written as P equals. HO is never written as P hat. HO is written as mu equals. HO is never written as X bar equals. All right. So we do not use the sample statistics. All right. So this is close, but this is better. All right. Got a bunch of E's there. 64, 63, 61. That's a lot of E's. 65. There are 50,000 high school students in an extended metropolitan region. As each of their students came to register for classes, guidance counselors were instructed to use a calculator to pick a random number between 1 and 100. If the number was 50 was picked, the student was included in a survey for one of many survey questions. 30% of the students said they couldn't live without any instant messages. Are all conditions met for the constructing a confidence interval for the proportion? Well, let's see. It looks like they used a random sample because they used a random number. So random, that was done. There are 50,000 high school students. All right. And as each one came in, they selected a number from 1 to 100. So that means, what did they do? 50,000 divided by, you only had a 1% chance of being selected. So, because 1 out of 100. So 50,000 times 0.01. So they only had a sample size of 500. So N is 500. And if we go 500 times 10, well, that's definitely 500 times 10 is 5,000. Well, 5,000 is definitely less than 50,000. So N is less than 10%. So that's good. So random sample. So now we need to check the NP. Well, what did they say? 30% said that they couldn't live without messaging. So 0.30 times 500 equals 150. And then we have 1 minus that, which is 0.70 times 500 is equal to 350. Both of those are greater than 10. If both of them are greater than 10, then yeah, looks like all the conditions are met. And look, we have another E in a row. Wow, that's a lot. That freaked me out. Which of the following statements is incorrect? The significance level of test is the probability of a type 2 error. That's incorrect. Hey, it's not E. Alpha is type 1, and that's the significance level. So that's incorrect. 66 is A. 67. Which of the following is a true statement? The p-value of the test is the probability of attaining a result as extreme or more extreme than the one obtained, assuming the null is true. That is also a true statement. All right. 68. In a random sample of 500 women, 315 said they'd rather be poor and thin than rich and fat. In a random sample of 400 men, 220 said they would rather be poor and thin than rich and fat. Is there sufficient evidence to suggest that the proportion of women who'd rather be poor and thin than rich and fat is greater than that for men? So let's go ahead and set up our hypothesis. Our hypothesis is that there's no difference. So I'm going to say HO, the proportion of women, equals the proportion of men. The HA, the proportion of women, is greater than the proportion of men. And for women, we have, X equals 315 out of a sample size of 500. And for men, we have 200 X equal to 220 out of 400. So let's take a look at that. Stat, test, two proportions z-test. So 315, 500, 220, 400. We said greater than. We calculate, and I get a p-value of 0.007. All right, 68. 0.007 is less than 0.01. That is very strong evidence. All right, that's a lot of evidence. We're probably going to reject that, say there is a difference. All right. 69. For a given large sample size, which of the following gives the smallest margin of error in calculating a confidence interval for the population proportion? All right. If you want a smaller margin of error, as confidence level goes down, ME goes down. So let's look at that first off. Which ones have the smallest confidence level? Well, A and D do. A and D are at 90. They have the smallest confidence level. Here we have to be careful. If we want the smallest confidence level, we have to consider what our interval is, well, let's look at our formula. P hat plus or minus Z star, and then the standard error is P hat times 1 minus P hat over N. Well, I want this to be small as possible. So I want big N. Well, they didn't ask me about N, so I don't have a big N to mess with. On the other hand, I can play with P. So the P that I'm going to want is 15, and I'll show you why. Because I need this area to be as small as possible. This part right here needs to be small. If I use 0.15 times 0.85, What do I get? 0.15 times 0.85. I get 1275. It's 0.1275. On the other hand, if I use this value, 0.23 times 1 minus that, which is going to be 0.77, 0.23 times 0.77, I end up getting 0.1771. This is bigger, and I want the smaller one. So the smaller one is going to be this 15%. All right. Um, so if I want a smaller margin of error, this needs to be small. All right. Any of the things I'm multiplying by. 70, a random sample has been taken from a population. A statistician using this sample needs to decide whether to construct a 90% confidence interval for the population mean or a 95% confidence interval for the population mean. How will these differ? All right. As the confidence level goes up, margin of error also goes up, which means it gets wider, right? As confidence level goes up, margin of error goes up, which means it's wider. The 90% confidence interval will not be as wide as the 95% confidence interval. That's a true statement. Let's see if there's anything better. The 90% confidence interval will be wider. That's false. It says, which depends on how large the sample is. That could be true, but the sample has already been taken. So we don't have to worry about it. All right. Bias has nothing to do with it. Bias is whether or not it's even trustworthy. Okay. Which interval will depend on whether a z statistic or a t statistic? No, it's a proportion. It'll be a z statistic. If it's a sample, it'll be a t statistic. That has no impact on it. Our best answer to number 70 is A. All right, I appreciate you watching and hope to see you on the next one. Thank you.